People were out observing the aurora, and they started noticing something that was overhead as well when they were seeing the aurora far to the northern regions. It was unlike most aurora. Talked to the scientists, we didn't know what it was, and together they said, we'll keep taking observations and we'll call it Steve in the meantime. Steve is mostly a very narrow purple arc, and sometimes it has these little green features that go along with it as well that are kind of like waving fingers or a picket fence. That means that there's plasma physics happening up there to cause that light and to make these little discrete features that we don't understand yet. Steve is important for a number of reasons. It's really exciting that people armed with cameras all over the globe can capture something that we didn't fully understand and shed new light on that. It's also really exciting that this happens further to the south where there are more people, so it might be a kind of aurora that more people can see than the usual kind. We're now able to look up at the sky and see things about the aurora and this subauroral region that we never understood before, and then we can correlate that with our traditional observations and lead to greater understanding.
Auroras are spectacular. These dancing lights visit the polar skies when charged particles strike the Earth's upper atmosphere, causing the atoms and molecules there to glow in a variety of colors. Now there's a new dancer in town, a thin purple arc named Steve. The phenomenon was first spotted by citizen scientists observing the aurora. In addition to its unusual color, Steve also stood out based on its location. It appeared closer to the equator than other auroras, which are typically spotted at latitudes between 65 and 80 degrees. The regions of the atmosphere where these light shows normally occur form a large oval over each magnetic pole of the Earth. During times of increased solar activity, these ovals broaden, moving toward the equator. This feature, dubbed Steve by citizen photographers who were surprised but it just kept showing up in the skies over southern Canada, was a narrow purple line in the night sky. Citizen photographers have captured hundreds of images of Steve over the last few years, usually during times of increased auroral activity. In July 2016, the European Space Agency's Swarm-A satellite flew over Steve, revealing that a previously known phenomenon called subauroral ion drift, or SAID, may explain its unusual properties. SAIDs are narrow regions of charged particles moving rapidly to the west, sometimes at speeds exceeding 5 kilometers per second. Researchers believe that Steve is simply an optical manifestation of an SAID, a phenomenon that's been measured before but never seen. Thanks to satellite data and observations from citizen scientists, researchers now have a better understanding of this atmospheric feature. In a nod to the original informal name, scientists have suggested that it be called a strong thermal emission velocity enhancement, otherwise known as STEVE. The discovery of STEVE helps highlight the importance of citizen science and the many ways in which professional scientists and enthusiastic amateurs work together.
So you understand what I did there? With that animation? With the gavel? What did I do there? Who knows? Take a guess. What did I do? You want to watch it again? Let's watch it again. Did you see what I did? What did I do at the top? of the, whatever you want to, there's a special name for it. I don't know the name. It doesn't matter right now. What did I do to the top of the little stair-stepping thing, platform? I hit it, yeah, with my gavel, and I left an impression into the lead or whatever metal they use for that. I left an impression. And when you notice my artwork, when I display my earth to you, you are left with an impression. You cannot deny it. You are left impressed by my talented display. There's a reason I didn't go deeper into the 3D realm of things. I could have gotten more into character animation and inverse kinematics and all that stuff. But I had to do the basics for a reason. I had to build my foundation, my physical foundation, my housing. And I focused on that. And I avoided what caused me strife. And I rested. And I waited for the right timing to reveal to you certain truths about my earth. And you can go back in history and watch previous older videos and see the chronological progression of refinement. And now I feel satisfied with enough information to show you about my earth. Maybe something down the line later, a little bit more. I might get into more about how the light goes through the glass and creates the 46-degree halo. I mean, I already showed that with the moon, this glass sphere covering the moon and the glass sphere covering the planets, and that creates the 22nd and the 46th. But like showing how the light kind of flares out from the sun. I showed you the onion shape of the sun, but what I wanted to do is show you, like, visually how there's a certain angle of incidence that the light coming out of the sun and bending up toward, converting toward that onion shape. But there's a certain angle of incidence. I don't know what it is. I don't want to spend the time to study and research it. Maybe you all can figure it out. But there's a certain angle of incidence in which I believe it's going through the glass and creating and dividing up the spectrum, the white light into the spectrum colors. And so that angle of incidence, I'm guessing, might be the same angle of incidence in which it intersects the glass sphere surrounding the moon. But you already get the foundational understanding, and that's how we get the 22nd and 46-degree halos. Because there's a glass sphere covering the sun and the planets, and there's a glass sphere covering the moon. It has some form of negative refraction quality to it, with some kind of phase conjugation and wave coherence. And then there's also a glass sphere much lower at 100 kilometers, or about. And so that leaves you with an impression of understanding. And in order to brand that, if you understand the word impression, it can, one, make someone feel admiration and respect, or two, make a mark or design on an object. You all are objects, using a stamp or seal, imprint. stamp or seal. And that is what I require from you guys. That if you want to partake into the richness and utter blissful peace, full experience of the joys of my kingdom, I have to leave an impression upon you using a stamp or seal. An imprint. Yeah. You know what I mean? I think you know what I mean. We're talking about that. On your skin. Leaving an impression on your skin. The covenant by sacrifice. We have an impression in the sky because there is glass above us. And we get the aurora. And that one particular impression, it's very strong. Thermal emission velocity enhancement. I left you an impression in the sky, a signature like Picasso would sign his painting at the bottom right. Steve, my earth, I sign my work of art, and I retire.
Hi guys, I'm going to try to explain the auroras, how they work, how they really work, because obviously the Earth is concave and there's glass in the sky, and the glass acts like a vacuum tube, like a vacuum chamber, like a plasma ball that contains plasma, in which solar radiation is hitting the geomagnetic radiation of the Earth. I think the Earth has a metal rind to it. I think that this metal rind is slightly tilted. I believe, let's go to my lightweight program, the cutaway of it I believe that the continental and the oceanic plates were formed over the metal rind, over the water. I believe there's a layer of water that's sandwiched in here. And Scripture says in Job 26 that I stretched the north over the empty place. I also believe that it was stretched over the south as well, where this area is just plate. There's no metal there. So the continental plates, the sedimentary rock was created by the water. And so it's stretched over. I don't believe there's really any, I mean, there might be some little pinholes here and there in the north and the south, but I believe it's been covered over like that with water. Now if you, if I grab the little lip here, the metal lip, you can see the auroral zone. Okay. It's also tilted, right? The magnetic North Pole, magnetic South Pole, or the geomagnetic North Pole and South Pole, they're tilted. So they're not going to be exactly in line with the true north, the true geographic north, or the geographic south. They're going to be slightly, it's about 10 to 11 degrees. So it's just tilted a little like that. So now you can understand why there's a difference, why the auroral zone, it doesn't line up perfectly with the geographic north and south. And so this auroral zone, actually I tilted it the other way, I should probably It's like over Canada. Let me quickly tilt that the other way. There we go. There we go. So it's tilted like that. It's also interesting that the poles are flat, right? Well, that would make sense. If it was stretched over with sedimentary rock that created the plates, there's no metal there, so I mean the poles of the Earth are flat, right? So this auroral zone, okay, it's just mimicking the opening of the metal rind. This is my theory. And this magnetism of the metal Earth, the metal rind of the Earth, it's coming out from the north, it's going around the outside of the Earth, and it's coming right back up, shooting back up north like that. There's declination within the Earth, magnetic declination. That's like these vertical, semi-vertical lines going throughout the Earth that are caused by a deviation of the vertical magnetic flux. So the continents, you know, there's stuff in the continents, whether it's metal or whether it's changing the direction slightly of the magnetic deviation, which wants to go perfectly vertical. So the sunlight within the Earth, here's the sun's rays. During the auroras, the end of the sun's rays, the auroras happen like in the cold, in the wintertime, or getting close to the wintertime. So let me just tilt that sun a little bit down. Like that. Just bear with me. Bear with me. Tilt it down a little bit. Okay. Now, the end of the rays are going to interfere with the auroral zone, the magnetic activity coming up from the lips, from the metal lips of the rind of the Earth. Okay, it's not the magnetosphere, the glass sky. It's causing the vacuum, creating the plasma, creating the nitrogen and the oxygen. There's still a little bit, and it's not a complete vacuum, so there's still some nitrogen and oxygen above the glass, which is creating the striations, this interference, the solar wind, the end of the curved rays of the sun interacting with the magnetic flux of the lips of the metallic rind of the Earth. That's how I believe. So this metal, it's shifting, it's moving, it's the waters that's sandwiched between, or the oil that's sandwiched between, is shifting. So you have the inside of the Earth, heaven, it's staying perfectly vertical. Okay, it's not shifting whatsoever. But this outer metal rind is, over the years, okay, the magnetic North Pole is moving every once in a while. So that's what I believe is happening. That's how I believe the auroras are happening. Auroras happen in this state, within a vacuum, with glass. Glass acts as the insulation, the insulator. So it blocks all these rays, the solar radiation, and it creates the striations like that. Don't let them tell you differently. Talk to you later.